All right, well, thanks for sticking it out, 2 o'clock. Come on in. We have plenty of seats up front. Plenty of seats. Special discount. All right, well, we'll go ahead and get started. So almost 7 years ago, on August 23rd, there was a 5.8 significant earthquake in Mineral, Virginia. And so the image you're seeing on the screen is some data that we collected about the particular event. And so my question to you is, did you feel it? So I'm Tim Woods, and I'm with the U.S. Geological Survey, and this is Brian Lacey, and he's CEO of Mobomo. And together, we're working on a project on Alexa scale, and the first one for USGS. And so USGS, this is who I represent. We're the federal government. You've probably seen this logo before. If you read in the news ever about an earthquake or potentially a volcano that's erupting, you're going to see our name. USGS is America's largest earth science agency, and we study everything from the sky to below the ground. So that's water, obviously the ground, minerals, ecological systems, you name it, we study it all. And one thing that's really interesting that spurred the idea for this particular Alexa skill we're going to show you is we operate sensor networks all over the world with partnerships or ones that we own altogether. And so we know when the earth is shaking, we know when North Korea lights off a bomb, we know what the magnitude of that is. We have stream gauges all over the place, all over our country. So we know when things are flooding. We have sensors that go out when hurricanes come in. And a lot of the rest of the federal government that you guys hear a lot about, NASA, EPA, NOAA, they all rely on USGS's data. So that's who we are. We're kind of the scientists behind everybody else.
Like I said, my name is Brian. I'm the CEO of Mobomo. We are a DC-based creative and cloud agency. We like to say we solve elegant problems. We create elegant solutions to solve complex problems. For amazing clients like the USGS, we focus mostly on large-scale mission-critical websites like NASA, USGS, NOAA, and the GSA. We also do a lot of mobile apps. We did the official apps for the White House, the Navy, the VA, and we do work for Gallup and Mars Chocolate.
All right, so we're going to talk to you about a skill that we're building, and it's in the realm of earthquakes. And so USGS does a lot when it comes to earthquakes. We have a lot of products and work that we do to look into why does an earthquake happen. So all the before an earthquake. We have a lot of products that and science that we do that is during the earthquake, and then we have a lot of products for post-earthquake. And so the one we're going to focus on today is this one called Did You Feel It? And so on this map is Did You Feel It data. And so Did You Feel It right now in its current form is a web application, and people fill out the web application, and it's a way for USGS to collect citizen science. And why is this important? It helps us understand how people experienced an earthquake. We have the sensors, we know how the sensors experience the earthquake and what does that mean to, in the ground and things like that. But the sensors can't tell us if a chimney fell over or stuff fell off the walls. So having people give us that data is critical. The Did You Feel It web application is just that. It's a very simple form, and it's standardized questions. And so we've taken that and turned that into an Alexa skill. So you can see, the coloration on the map, and these are all responses from folks all over the country. And so did you feel it? This is our Alexa skill. And this is a really kind of amazing thing for USGS because citizen science is critical. We do more than just earthquake citizen science. And but this one is one of the most popular ones. And every time there is an event, we get a lot of traffic and a lot of data. And so by combining this with voice, it's more natural now to solicit this information from folks. Again, this data helps our scientists come to understand what happened really. The sensors tell us a whole lot, but the data from folks really helps us as well. And we produce a lot of products and a lot of maps that we will overlay the seismic data with the actual accounts of people. And the resolution gets pretty granular. We get down to 10 meters. This is what the experience was like here and there. So adding this to voice is like a natural fit for us to move forward. And it's our hope that this really, puts the website to shame and everybody just uses their Alexa device to talk to USGS and say, this is how we experienced the earthquake.
So when it comes to government services, we definitely view voice as being that next level of communication. It brings a level of accessibility that a website suffers from. You don't need to worry about things like 508 compliance. It's natural and it's intuitive. It gives you both immediate feedback and for both parties, for the user and sending that information back to the government. It works well in situations where you want a more personalized experience. In a disaster situation like an earthquake, this would fit better into that. And then the vision is that it's going to create a better psychological impact on the user because they're having a better interaction with the government. And more services like this will kind of lead towards that initial goal. So we're going to go through the demo now.
Alexa, open earthquake tracker.
Let me ask you a few questions from the U.S. Geological Survey's Did You Feel It questionnaire. This should take a few minutes at most. At any time, say help for complete instructions. Do you want to report an earthquake to the USGS? Say yes or no.
Yes.
Were there other people nearby? Say yes or no.
Yes.
Did the others feel the earthquake? Say no others, some others, most others, or all others.
Most others.
Which word best describes the shaking? Say weak, mild, moderate, strong, or violent.
Moderate.
Which of the following describes the reaction? Say no reaction, very little reaction, excitement, somewhat frightened, very frightened, or extremely frightened.
Somewhat frightened.
Was it difficult to stand or walk? Say yes or no.
No.
I'd like to ask about objects swaying, moving, or falling. If you did not see or hear anything, just say, finished. Did you see any swinging of doors or hanging objects? Say no, slight swinging, violent swinging, or finished.
Slight swinging.
Did you hear objects rattling or shaking? Say yes or no.
Yes.
Did objects topple over or fall from shelves? Say a few things, many things, or nearly everything.
A few things.
Did pictures on the walls move? Say yes or no.
Yes.
Did furniture or appliances slide, topple over, or move? Say yes or no.
No.
Did you observe any cracks or damage to your structure? Say yes or no.
No.
Okay, let's review. You felt an earthquake at 1600 Spring Hill Road, Vienna, Virginia. There are other people nearby, and most others felt the earthquake. You felt moderate shaking. You felt somewhat frightened, and it was not difficult to stand or walk. You witnessed some slight swinging of doors or hanging objects, and you heard objects rattling or shaking. A few things toppled over or fell from shelves, and pictures on the walls moved. Thank you for reporting this earthquake to the U.S. Geological Survey. If you would like to learn more, please visit usgs.gov.
All right, so what you saw there was the web-based form turned into an Alexa skill. And so felt like a lot of questions standing here on stage as you guys were watching us. And so this is part of our challenge as, Brian and I are technologists. We're working with scientists, and they have to have that scientific rigor. The questions that they have are accepted in the community. And so this is where we're going to go next. And this is kind of the first step in a big vision. And so this conference this week has all been about the smart home. We've heard it over and over again Alexa, turn on my lights or my air conditioning and things like that. And that's all fine and good. And we really like, the commercial aspects of Alexa. But at USGS, we're starting to think of it, here's a technology platform and here's an opportunity to really engage with citizens in a two-way dialogue. And we like to think about using Alexa to create the scientific home. And, in some future iterations, as we combine more data and as the platform potentially grows to do notifications and things like that, we like to think about it as really creating the safe home as we're able to share, real-time data about hazards and events. And so, again, like I was saying a moment ago, the next direction we want to go with this is it's really about learning. Voice is so brand new. And, I heard a lot this week about people testing not only the software they're creating, but testing users and methods for testing users to try and develop the perfect, voice skill, whatever it might be. We want to learn, obviously through the collection of data as people interact with this and iterate over it and make it better. We need to do more things to make it more conversational. It's, to me and Brian, it still feels a little bit rigid and boxy, and so we have to work to open it up, but at the same time, keep that scientific rigor. Down the road, we want to tap into more data. We have tons and tons and tons and tons of data. And so we want to figure out how can we get that more accessible through the voice platform and interactions. We are working on some other voice-enabled things. We have a huge FAQ library of scientific information. And so we're working on that to bring it to our front-end website, but we'd also like to bring it to Alexa as well, so people can ask the all-important question like, can I drink glacier water? We need to work with Amazon and understand where they're going. And the notification thing is a real big deal. And if you think about the state of California, the threat of earthquakes out there is huge, and it means a lot to those folks compared to what did it mean to the East Coast when we had that earthquake in 2011. So we do have a lot of early warning type of things, and so again, a partnership with Amazon and others would be key because we could get that information out in just one more channel. Everybody's got phones, everybody's got TV, and soon everybody's going to have a smart speaker. The other area we want to go is visualizations. We create a lot of maps where stuff is happening. And as we get Did You Feel It data through the website, we're instantly calculating a map, putting your location on the map, and we'll show you the seismic data. We send that back to folks generally through that web page. We'd love to add this to the Echo show. How cool would that be? You could talk to it, and then she shows you the map, and here's you, and then here's where the earthquake was, and here's what the sensors say anyways, the significance of shaking in the ground. So we got a lot of big ideas.
So I'll talk a little bit about what's like working with the federal government, putting together a voice-enabled app. We were lucky that the USGS was actually set up for success because they are an API-rich organization. They have a huge amount of information, and it's all consumable over APIs. So we're able to then leverage that and easily access it via the voice platform and bring it back. So in future generations, we're going to be able to quickly grab from their fact files and say, tell me the latest on volcanoes, or tell me about the volcanoes in Hawaii. And that information is already there in a consumable format, and she can just speak that to you. On the challenge side, like working with any government organization, we have to be very aware of the laws and the regulations about putting any kind of information out there. So we just have to build that into your timeline of working and getting permissions, working with their legal teams before you're actually able to launch something. And then, as you saw with some of the questionnaires that we put up here, new technologies with traditional forms of collecting information from the science side actually kind of come in conflict. Most of the time they were using clipboards and paper to get this information, or that web app, which is long and kind of confusing, putting it into a voice format and making sure that the information is scientifically valid was more of a challenge for us than we anticipated. Some of the other aspects of it is, they were used to things being like, yes or no. And then if you said, Alexa, did you feel an earthquake? It's like, yeah, I felt an earthquake. But, and here it's like yes or it's no. So being able to anticipate those type of responses was a difficulty that we came up against. And then, with all these things that we're seeing, being able to anticipate, sentiment and the emotional reaction to a lot of these things and how the government can start using that in the future is something that we're looking into. And so all these kind of things really came up to the biggest issue for us being scientifically valid data. These same questions that they had before we used for decades upon decades. And figuring out a way to actually put it into a voice format that was scientifically valid was actually the biggest difficulty. And what you saw there in the demo was actually where we actually came to a good compromise. Moving forward, we like to get to a little bit more of a natural language processing piece of that, so it's a lot more intuitive.
So infrastructure improvement. So I'm happy to say that USGS is moving to the cloud. We have a lot of things in the cloud, and we're starting to realize the benefits of the cloud that the commercial industry already has. And so things like Alexa can only become possible because we have stuff in the cloud. And the whole concept of serverless architectures and cheap, data storage are what makes things like this possible. And so, not everything's there, but we are moving major systems there. And as we do that, hopefully as, the smart speaker platform and that stuff continues to grow, we'll be able to do more and more interesting integrations to combine both visual information with the auditory information at the same time.
Oh, and then some of the other technical limitations that we had is for the GPS position, we had to be within 10 meters. So if I bought Tim an Alexa and then he just set it up on his home, put in the Wi-Fi and started using it, it doesn't know where he is. If I bought an Alexa off of AWS, it's already linked to my account and knows my address. We could quickly just grab that information and get a pinpoint accuracy. So if someone didn't set up that address piece during the entire flow, we'd have to ask them, what's your street, what's your city, what's your state? And that caused a little bit of conflict in the overall experience. On the Echo Show side, the number of templates that we could work with on the display side was extremely limiting, so we're looking forward to see what they come out on that side. And factor that in with the dot, with the small, or the smaller versions where they just have the circle. The visualizations was tough. And then the testing was actually really difficult for us because early on, there was not an easy way for us just to send the build to other people that could actually look at it. So we actually had to go back to more of the 90s style of testing, bring people into a facility, bring them into a room, put them in front of the Alexa, have them go through the experience, and then actually fill out a form and tell them what they thought of it. So we're looking forward to seeing what they can come out with more of an agile approach to testing, that we can send links out to people and they can give us immediate feedback. So we'd like to open up to any questions anyone might have.
We have plenty of time for questions.
I've got one actually. So for emergency alerts, they're typically on for text alerts, they have to be like 30 degrees. And do you see that changing for voice alerts about earthquakes and such? Or do you think it'll be the same format?
No, in the California model that I was talking about, they are working on a program called Earthquake Early Warning. And so we're talking with the cell phone vendors and things like that. And so, the density of Los Angeles makes it incredibly difficult to send out a message to everyone.
Yeah.
Even if the packet is just a couple bits, multiply that by millions, right? And so the airwaves are completely overloaded. And, they are looking for other avenues. If we're able to offload some of that through an Echo device or another smart speaker or something like that, it might be something just as simple as the ring color, is spinning a certain color, and that's it. And then you say, Alexa, what's going on? You potentially feel the earthquake too. And then she's able to, chime in and say whatever she wants to.
So is there a way to automate the survey so that it actually automatically collects the data and says, can I send this report or something like that? Like we're assuming that there's camera and other things.
Yeah.
Involved as well.
Anything's possible. We can take in any kind of data. The only issue is it just always has to be standardized in some way, because without standards, then how can the scientific community from anywhere go, oh, that really was, X, Y, or Z. So that's kind of the tricky part with taking data from anything.
And you guys working on new standards, or because at some point you have to shift to a new model?
And that's an interesting point, because if we get into this conversational UI,
Yeah.
and if the smart speaker is able to discern your emotions,
Yeah.
what does that do to our questions? The questions are, attached to this scale, and they mean, what they mean. But if we're able to take the emotional response, you're screaming and yelling at Alexa. Well, emotional response is pegged at a 10. How does that influence, the event report? So these are interesting things that we're going to begin looking at in the very near future. Great question. No question? Yeah, sure.
I guess, just moving off from that, I was thinking about your intelligence assessment. Since there's, someone's experiencing an earthquake that's powerful or not, they might not report this right away. The perception of that event, for instance, is there like a time window that you're aiming for to get people to report what they're seeing, if you're working on scale, or is there an expectation that you're doing that? Sort of get them to make a report, so that whatever data that is that you're collecting is actually accurate of that.
Yeah, in parts of the country where there's a lot of earthquakes, we are well known, and the web-based version of this is well known. So we want to do whatever we can to get the Alexa skill aspect of it well known. The typical pattern is if there's a significant earthquake that people feel and they are going to interact with us and give us data, they typically do it within 90 minutes is what we see. So it's very sporadic, and it's these gigantic spikes. We get, in the web-based form, we'll get 100,000 requests a second, and it maintains like that for a period of time. So scaling with Alexa is an issue that we're working on, and how can we take that in? How can we have all the Lambda services warm, so they can just fire? And so we're not worried about, was it 10 hours later and you said something about the earthquake, because people typically do it right away. And through some work that we've done, we've come to understand that it's kind of a cathartic moment for folks to be able to share their information, even through the web-based form. So we're really excited to see what happens when you can actually talk to Alexa, and she's very friendly and polite and says stuff, and maybe we work on the conversational UI a little bit more, and it's even better. So this is a wide open area. It's all brand new, and being a technologist, I'm just excited to be able to have the opportunity to do a project like this and really make an impact for society and also for the federal government. Anybody else?
Thank you very much.
Thanks for your time.